We're going to be working with exponential growth and decay. We're going to be working on some problems that are on worksheet 12.1. The first problem that we're going to be looking at is going to be determining population using an exponential growth equation. So the first equation that we're going to be using is y equals a times the quantity 1 plus r to the t power. A is going to represent your initial or starting amount of population. R is going to be your percentage, but you're going to change it to a decimal. And T is going to be the number of years. So we're going to go ahead and take a look at number 1. And we're going to do our substituting of our information. So the first thing that you want to look at are your numbers. And there's the first number they give us is a rate of 0.91%, the population in 2008, and we are predicting the population in 2012. So we're going to go ahead and fill in our numbers. Y is equal to A times the quantity 1 plus R to the T exponent. So y is equal to our substitution step, 303,146,000 times 1 plus, and then a reminder that we have a decimal. So we're going to put that into our DRP chart. We have 0.91%. In order to change it to a decimal, it's currently a decimal percent. We only want to make it a decimal. So we're going to go 2 places to the left. So we're going to move that decimal 2 places to the left, which is going to give us 0.0091. Go back up to our formula, put in our R, 0.0091, and then in order to find our T, we're going to take the 2 years, we're going to find the total years that we're looking at. So we're going to do 2012 minus 2008. Y equals 303,146,000, 1 plus 0.0091, and that's going to be to the 4th power. So now we're going to come over here to our calculator. Because we're working with such large numbers, we're going to need to adjust our settings. So we're going to go to Document, Settings and Status, which is number 7, Document Settings, and we're going to take our digits and we're going to float to 10. Click OK. And now we're going to go ahead and put in our equation. 303, 146,000, parentheses, 1 plus 0.0091, parentheses, and caret to put our exponent in, 4, enter. So our answer is going to be y is equal to the population is about 314,332,051. We didn't round because it was decimal 4. All right, another growth exponential formula that you're going to be working with is going to be the investment formula for compound interest. For this one, our A, capital A, is going to be the account balance. That's how much money is left in your account after the interest has been added. P is your principal. This is the starting amount of money that is in the account prior to the interest being added. Your rate is going to be given to you as a decimal, or sorry, as a percent, and you're going to change it to a decimal. The N is the number of times that the interest is going to be determined and added. So a couple of terms that you're going to want to be familiar with. If you compound money quarterly, then the N is going to be 4 quarters in a dollar, 4 quarters in a year. If you compound monthly, your N is going to be 12 if there's 12 months in a year. If you compound weekly, the N is going to be 52 because there's 52 weeks in a year. And then our time is also going to be in years. So we're going to take a look at number 2 and look at what our numbers are that they have given us. So to start with, we have $2,500, which is going to be our principal investment. So that's the amount we're starting with. We're investing at 5.25%. We're compounding monthly. Monthly means our N is going to be 12 months in a year. And we're going to do this for a period of 4 years. So let's go ahead and plug in what we know. A equals 2500, that's our principal, times 1 plus. Again, we have a decimal percent. So we're going to come down here to our DRP chart. And we're going to put 5 decimal to 5%. We're going to change that to a decimal only. So we're going to move the decimal 2 places to the left. 0.0525 is going to be our rate. So put our fraction in, 0.0525. We said that it's being compounded monthly. That gives us an N of 12. And now we're going to put 12 times the total number of years that we're doing this, and that's going to be 4. So we have A equals 2500, 1 plus 0.0525 over 12 raised to the 48th exponent. A equals. We're going to go to our calculator. So we're going to go 2500 parentheses 1 plus control divide 0.0525 arrow down. 12 is our denominator. Arrow out. Exponent is 48. Enter. And that, now this is money, so you need your label. So you're going to have your dollar sign, 3082, decimal 78. So that is how much money is going to be left in your account after you have compounded interest for 12 months at compounded interest monthly for 4 years. Okay, the last formula that we're going to look at is the exponential decay formula. Again, A is the initial amount. R is your rate, which will be given to you as a decimal, or as a percent. You will change it to a decimal. And T is your years. So if we come down here to our decay or depreciation problem, the first problem that we're going to be doing is population exponential decay formula. You're going to use the same exact formula when you're determining depreciation. That is how much something is worth after a number of years. And of course, after you purchase something brand new, it depreciates, so it's worth less. Good example is a car. If you buy a $25,000 car and you go to sell that $25,000 car, you're not going to be selling it for $25,000. You're going to be selling it for less. All right, so let's go ahead and look at our information here on population. It's decreasing annually at 0.89%. They give us our beginning population in 2005, and we're predicting the population in the year 2015. So we're going to take our information that we know. It's going to be y is equal to 7,450,349 times 1 minus. Again, we're going to do our DRP chart. And our rate is 0.89%. It is a decimal percent. We want it to be just a decimal. So we're going to move that decimal 2 places to the left. So it's going to be 0.0089 parentheses. And then we have 2015 minus 2005. So y is equal to 7,450,349, 1 minus 0.0089, and that is going to be raised to the power of 10. I'm going to go to our calculator. 7,450,349, parentheses, 1. Notice that we're subtracting because it's decaying or the population is getting less. 0.0089, parentheses, exponent 10. Y equals 6813 204. And you notice that we rounded it to the 4 because it was decimal 7. And now you know how to use exponential growth and decay functions.